Enough talk. Let's start here. Number 7. Gaia 17 BPP, the star that vanished for 7 years. Stars don't just go dark. That's one of the most basic rules in astronomy. They dim slightly in cycles. They flicker when something passes in front of them, but they follow patterns. Patterns we can measure, predict, and explain. You can set your watch by a star. Astronomers have been doing exactly that for centuries. But in 2017, University of Washington astronomers Anastasios Xenadakis and James Davenport were combing through data from the European Space Agency's Gaia survey, a sky mapping mission designed specifically to flag stars behaving strangely, when automated alert pointed them to one that had been gradually brightening over the past 2.5 years. They assumed the star itself was changing. Then they ran the follow-up analysis. The star wasn't changing at all. It had simply been hidden, completely, for roughly 7 years. Something enormous had eclipsed it, and the whole astronomical community had walked right past it. Here's why that's strange. When an object passes between us and a star, we typically see a brief, clean dip, hours, sometimes days. Even a planet the size of Jupiter blocking our own sun would only dim it by about 1.2%. But Gaia 17 BPP had been in near total darkness for approximately 2,500 consecutive days. Xenadakis and Davenport dug through the DASH program, a digital archive of over a century's worth of astronomical photographs at Harvard, and found 66 years of perfectly normal starlight. Then the darkness began. Whatever was blocking it had to span a distance comparable to the gap between Earth and the sun. Imagine you discover a photograph of the same house taken every single day for 66 years. Every photo, lights on, curtains open, car in the driveway, completely ordinary. And then, one day, the photo shows only a wall. Something vast is blocking the camera. Something that appeared without any announcement and is so large, it covers everything. You go to investigate 7 years later, and the wall is finally, slowly starting to lift. You don't know what it is. You don't know how it got there. You just know it's moving away now, and you just barely caught it leaving. But it gets worse. The team found only a tiny handful of similar systems in history, stars with enormous dusty disks in orbit around a companion. The most famous, Epsilon Aurigae, gets eclipsed for 2 full years every 27 years. But Gaia 17 BPP's eclipse lasted roughly 3 times longer than that. And the eclipsing object appears to be moving so slowly that the next eclipse may not occur again on any timescale useful to modern astronomers. We caught a single 7-year event that may only repeat once per human lifetime, or longer. Whatever blocked this star is still out there, drifting, unhurried, enormous. If you were to point a telescope at Gaia 17 BPP tonight, it would look completely normal, steady, and bright. You'd see nothing unusual. But there is a disk of material large enough to blot out an entire star circling it right now, on a path we can't fully trace. And one night, with no warning, it'll start again. And we'll know something huge is there. We just still won't know what it is. Gaia 17 BPP is a reminder that a star can be hidden in plain sight for decades while we're looking right at it. We are astronomers who've cataloged over 1 billion stars and still got surprised by a 7-year eclipse we almost missed entirely. Number 6. Betelgeuse, the Great Dimming. Betelgeuse is the bright orange star on the shoulder of Orion, one of the most recognizable objects in the night sky. It's one of the largest stars in our galaxy, so enormous that if you placed it where our sun is, its outer surface would reach past the orbit of Jupiter. For over a century, astronomers have tracked its regular pulsing cycle, brightening and fading on a predictable 420-day rhythm. It's one of the most studied stars in history, a known quantity, reliable as a lighthouse. But starting in October 2019, Villanova University astronomers Richard Wasatanek and Edward Guinan recorded something that had never appeared in any historical measurement of Betelgeuse. The star was dimming far outside its normal range. Not gradually, it was dropping off a cliff. By mid-February 2020, it had lost over 2/3 of its brightness, falling from one of the top 10 brightest stars in the sky to outside the top 20. You could notice it with the naked eye, standing in your backyard, looking at Orion. Something was visibly wrong. Astronomers used the word unprecedented. Some used less scientific words. Here's why that matters. A star's brightness is determined by nuclear fusion at its core, a process that runs on timescales of thousands of years, not months. It doesn't just decide to fade. Lead researcher Miguel Montarges at the Observatoire de Paris immediately pointed the European Southern Observatory's very large telescope in Chile at Betelgeuse and captured images that had never been taken before. The star's entire southern hemisphere appeared 10 times darker than normal. Astronomers were watching a star the size of our entire inner solar system change its appearance in real time over weeks from 548 light-years away. Imagine you look up at the sky and notice the moon is 1/3 of its normal brightness, not covered by clouds, not eclipsed, just dimmer. And it stays that way for 4 months. You call an astronomer and they say, yes, we see it too, and no, we are not fully certain why. That's what it felt like to watch Betelgeuse in early 2020. Except, this wasn't the moon. It was a supergiant star dwarfing anything in our neighborhood, and its face was changing while we watched. But it gets worse. The eventual explanation, a bubble of superheated gas erupted from the star's surface, cooled into a veil of dust and temporarily shrouded it, sounds tidy. But what the Great Dimming actually revealed is this. We still have no reliable method to predict when a red supergiant will explode as a supernova. Betelgeuse is expected to do exactly that sometime in the next 100,000 years. The event in 2019 and 2020 reminded us that this star is already in its final death chapter, its surface erupting, its atmosphere destabilizing, its appearance shifting on timescales of weeks. The next time it dims like that, it might not be a dust cloud, and we will have, at best, a few hours of warning. If you were standing outside tonight, looking at Orion and Betelgeuse went supernova right now, it would shine as brightly as a half-full moon, visible even in daylight. Spectacular for a few weeks. And then, gone. One of the oldest lights in human mythology, in every painting and poem and star map ever made, simply absent. No countdown, no alarm. It would just stop. Betelgeuse is not a mystery we've truly solved. It's a reminder that our cosmic neighborhood is changing in ways we don't consistently track, and that the most familiar things in the sky can still shock us into silence. Number 5. HD 139139. The random transitor. When a planet orbits a star and passes between it and us, it blocks a small fraction of the starlight. We call this a transit. The dip in brightness is predictable, precise, and, most critically, it repeats like clockwork. Every time the planet completes one orbit, it transits again. NASA's Kepler telescope found over 2,600 confirmed planets this way. The system is reliable because orbital mechanics is reliable. Things in orbit follow rules. They have to. In 2019, a team led by MIT astronomer Saul Rappaport published their analysis of a binary star system about 350 light-years away, HD 139139, which they formally nicknamed the Random Transitor. Citizen scientists scanning Kepler data had originally flagged it. During an 87-day observation window from August to November 2017, the telescope recorded 28 separate dips in the star's brightness. Interesting, but not alarming. Multi-planet systems exist. Then the team looked at the timing of those 28 dips. There was no pattern, none at all. Rappaport's team ran every statistical test available. They searched for any repeating sequence. They found that no more than 4 of the 28 events could belong to any periodic sequence. The arrival times of the remaining dips, in the paper's own words, could just as well have been produced by a random number generator. Think about that. Newton's laws of orbital motion are among the most rigorously tested principles in all of science. A pebble tossed into space follows a path you can calculate centuries in advance. For objects to orbit a star and block its light 28 times in 87 days, with absolutely no discernible period, is, by the known rules of physics, not supposed to happen. Imagine you're watching a metronome. Click, click, click. Perfect timing. Then, without anyone touching it, it starts clicking at completely random intervals. 4 fast clicks, then silence for 2 weeks, then 1 click, then 3. You've examined it. Nothing has changed. It just decided to stop following time. That's HD 139139. Except instead of a metronome, it's a star. And instead of clicks, it's something Earth-size crossing in front of it 28 times with no logic we can derive. But it gets worse. The European Space Agency pointed their Cheops satellite at HD 139139 in 2021 and again in 2022, specifically to watch for more of these transits. Over 12 total days of dedicated observation time across 17 visits, nothing. Not a single dip. Whatever caused 2008 events in 87 days had simply stopped, or moved, or went somewhere we couldn't see. The research team noted the uncomfortable possibility that whatever happened in 2017 was real and astrophysical, but is no longer doing it. It arrived. It dimmed a star 28 times with no logic. And it left. We have no classification for what it was. It doesn't have a name. If you trained a telescope on HD 139139 tonight, it would look unremarkable, steady, quiet. No evidence of the 28 unexplained events. And that may be the most disturbing thing of all, because it means whatever caused them is still out there doing something we simply cannot currently detect. HD 139. 139 is a star that obeyed no rules and then went silent. We built the most precise planet-finding instrument in history, pointed it at 500,000 stars, and found exactly one that appeared to operate outside orbital mechanics. We are scientists who mapped the laws of motion and found something that apparently didn't receive the memo. Number 4. Epsilon Aurigae. The star eclipsed by something invisible. Variable stars are well understood. Certain stars expand and contract, brightening and dimming in regular cycles tied to their internal physics. Binary systems can also cause dips when one star passes in front of another. All of this is explainable, charted, classified. The universe is full of stars that dim on schedules, and we have tools to read every one of those schedules like a calendar. But for nearly 200 years, astronomers have been looking at a star in the constellation Auriga, Epsilon Aurigae, about 2,000 light-years away, and trying to agree on what keeps eclipsing it. Every 20 to 7 years, the star goes dark. Not by a fraction of a percent, not by 5 or 10%, by nearly a third of its full brightness. And it stays that way, dark, for 2 full years. The most recent eclipse ran from 2009 to 2011, observed simultaneously by astronomers and citizen scientists worldwide. The conclusion, after nearly 2 centuries of looking at this star, something enormous, dark, and cold passes in front of it, and we still argue about exactly what. Here's the problem. Whatever eclipses, Epsilon Aurigae produces no detectable light of its own. It's dark, but it blocks enough starlight that its disk, because the best current model says it's a vast disk of material, would stretch, if placed in our own solar system, from the Sun roughly to the orbit of Saturn. That's 1.4 billion kilometers across, and yet it's nearly invisible. It's not a star. It doesn't emit enough radiation to account for any of our measurements cleanly. The companion at the center of the disk is likely a smaller, young stellar object, but the disk itself, at that size, in that configuration, around an object of that type, is unlike anything else we've confirmed in our galaxy. Imagine you've been watching the same outdoor lamppost every night for your entire life. It's steady and bright, reliable. And then, one night you notice it has dimmed by a third. You step outside, you look at it directly, and there is nothing between you and the lamp. No fog, no trees, no clouds, just open air, and a significantly dimmer lamp. And you know from old records that this happened before. In 1955, and in 1982, and now again. And each time it faded for 2 years, then slowly came back. Something is there, but you can't see it. You can only see the shadow it casts. But it gets worse. The disk around Epsilon Aurigae's companion may contain a dark central region, a band roughly in the middle of the disk that appears even less opaque than the rest. During each eclipse, the star appears to actually slightly brighten at the midpoint, as though light is briefly leaking through a gap. Something structured. Something with internal geometry. And we have no accepted model for how a disk of that size, in that configuration, forms and persists around an object of that mass. Every 2 decades it comes around. Every 2 decades we watch. And every 2 decades we write papers that end with more questions than answers. If you were to look at Epsilon Aurigae tonight, it appears normal. Steady. The eclipse ended in 2011. The next one won't begin until approximately 2036. But in the meantime, that disk, wider than our inner solar system, is somewhere in its orbit, slowly curving back toward alignment. Invisible, patient, returning on a schedule older than any living astronomer's career. Epsilon Aurigae is a clock we've been watching since 1821, and after 200 years, we still don't fully understand what the hands are made of. We are astronomers who've observed the same event 6 times across 6 generations, and still can't agree on exactly what we're seeing. Number 3, SGR 1935 plus 2154, the dead star that screamed. When a massive star dies, it can leave behind a neutron star. All the mass of our sun crushed into a sphere roughly 20 kilometers across, the size of a small city. Some neutron stars develop magnetic fields so intense they're placed in a special class. Magnetars. The strongest magnetic field ever briefly produced in a laboratory on Earth is about 100 Tesla. A magnetar runs at around 100 billion Tesla. They're extreme objects, but known, classified. Physics can account for them. But on April 28, 2020, something happened that had never happened in the 13 years since fast radio bursts. Those millisecond flashes of radio energy powerful enough to outshine entire galaxies in a single moment were first discovered. 2 separate radio telescopes simultaneously detected one coming from inside our own galaxy, from a magnetar called SGR 1935 plus 2154, roughly 30,000 light-years away in the constellation Vulpecula. The Canadian Hydrogen Intensity Mapping Experiment, CHIME, picked it up. STARE 2 confirmed it within the same instant. A team at the University of Toronto, led by astronomer Paul Schultz, was watching in real time. Here's what made this impossible by prior understanding. Fast radio bursts were supposed to come from other galaxies, billions of light-years away, because only something that distant could explain how bright they appear to us while still fitting any known physics. But SGR 1935 plus 2154 is inside our Milky Way, in our home. And it had just released the energy equivalent of everything our sun produces in an entire day, compressed into a single millisecond. STARE 2's measurements put the burst fluence at more than 1.5 million Jansky milliseconds. The previous brightest event ever recorded from any Milky Way magnetar was billions of times fainter. This object produced, without any prior warning, a sound on a scale that nothing in our galactic neighborhood was supposed to be capable of. Imagine you've lived in the same quiet neighborhood for years. You know every sound. The kids down the street, the dog next door, the occasional car alarm, all within a normal range. And then one night, without any warning, one house down the block produces a noise so loud it could theoretically be heard in another country. Not an explosion. Not a shockwave. A signal traveling outward at a volume so far outside anything your neighborhood has ever produced that it rewrites your understanding of what's even possible in a residential area. That's what SGR 1935 plus 2154 did on April 28, 2020. And we only knew because someone had left a radio telescope running. But it gets worse. Since that initial burst, SGR 1935 plus 2154 has continued. It repeated in May 2020, then October 2020. Researchers analyzing its behavior found that its bursts span 7 full orders of magnitude in brightness, meaning the faintest ones are 10 million times dimmer than the brightest. Chalmers University astronomer Franz Kirsten's team concluded that if magnetars across the universe are doing this, then beams of radio energy at incomprehensible scales are crisscrossing the cosmos in every direction, constantly. We are only now, with our best instruments barely sensitive enough, beginning to intercept them. Every direction you can point a radio dish, there are probably signals like this passing through it that we don't yet have the resolution to hear. If you were standing outside on April 28, 2020, there was no indication at all that a dead star 30,000 light-years away had just done the most energetic thing ever recorded from within our galaxy. No flash, no sound, no change in the sky. The signal passed through you, through your skin, your cells, and you felt nothing. The most extreme radio event in Milky Way history moved through your body while you were probably checking your phone. SGR 1935 plus 2154 is a dead star that woke up and announced itself in a language we were just barely starting to understand. It is evidence that the galaxy we call home has been throwing extreme events in every direction all along, and we've been mostly deaf to them. We are radio engineers who just discovered our quiet neighborhood has neighbors that occasionally shout loud enough to be heard across the universe. Number 2. Przybylski's star. The star containing elements that can't be there. Stars are the universe's factories. Through nuclear fusion and the violence of stellar death, they create every element on the periodic table. Every atom of iron in your blood, every carbon in your cells, it all passed through the interior of a star at some point. We understand this process well. We can analyze the light from a distant star, spread it through a spectrograph, and read exactly which elements are present from the patterns of lines that appear. It's a precise, reliable technique. Every fingerprint makes chemical sense. In 1961, Polish-Australian astronomer Antoni Przybylski was surveying stars at the Mount Stromlo Observatory in Australia when he turned his attention to HD 101065, a faint star about 356 light-years away in the constellation Centaurus. He began reading its chemical fingerprint. And then he stopped, because the lines he was seeing didn't fit any known stellar class. The iron lines, which appear in virtually every star ever observed, were nearly absent. In their place, extraordinarily high concentrations of exotic rare earth elements, holmium, gadolinium, terbium, europium, present at concentrations 1,000 to 10,000 times greater than in our sun. He published his findings in a letter to Nature and reportedly spent years defending them, because other astronomers thought he must have made an error. Here's where it becomes genuinely impossible. The chemical fingerprint of Przybylski's star includes radioactive elements with half-lives measured in years or decades, not thousands of years, not millions. Years. Elements like Einsteinium-254 with a half-life of 276 days, Plutonium-239 with a half-life of 24,000 years, possibly Promethium, whose longest-lived isotope survives for just 17.7 years. These elements decay rapidly. The universe is 13.8 billion years old. Any of these substances that existed when this star formed would have decayed into entirely different elements billions of years ago. They cannot still be present. But every time astronomers read Przybylski's star's spectrum, the lines are still there, still glowing, still registering. Imagine you open a room sealed for 1 billion years and find a birthday candle still burning on the table. Not the wax, the actual flame. Physics says that flame should have consumed every atom of fuel within minutes of being lit. The oxygen in the room is long gone. There is no reason for that flame to exist. But you see it clearly, and so does everyone else who looks in the room. That's Przybylski's star. It contains things that should have become something else billions of years ago, and they haven't. But it gets worse. Astronomers have proposed several explanations, and none fully works. One theory suggests an invisible neutron star companion could be bombarding the star's atmosphere with radiation intense enough to continuously manufacture new radioactive elements in real time. But no neutron star companion has been found. A second theory explored in a 2017 research paper, suggests the star may contain undiscovered super-heavy elements in a theoretical region of the periodic table, called the island of stability, elements so massive they haven't been synthesized in a laboratory, and what we're seeing in the spectrum are simply their decay products. In other words, Przybylski's star may contain elements that don't yet have names in human chemistry. And separately, Arizona State University physicist Paul Davies raised this in print. Is it possible that an advanced civilization has been using this star as a repository for radioactive waste? That one remains, formally, on the table. If you were to study Przybylski's star tonight with a spectrograph, you would see those lines, clear and undeniable. Elements that a billion years of nuclear physics says should no longer exist, burning in the atmosphere of a star 356 light-years away. You would be holding evidence of either a process that rewrites nuclear chemistry as we understand it, or something actively manufacturing impossible elements inside a star right now for reasons we cannot explain. Przybylski's star is the universe holding up a page from a periodic table we haven't finished writing. It either contains elements that shouldn't exist, or it contains a process continuously creating them, and we genuinely do not know which of those possibilities is more disturbing. We are chemists who've mapped every atom in nature and found a star that appears to have been ignoring our maps since before humans existed. Number 1. Tabby's star, the light that disappears for no reason. Here's how planets are found. When one passes between its star and us, it blocks a tiny fraction of starlight, typically less than 1%, often as little as 0.01%. The dip is brief, precise, and repeating, every orbit, like clockwork. NASA's Kepler Space Telescope found thousands of planets this way across 500,000 stars. The method is reliable because physics is reliable. Orbits follow rules. Period. In 2015, Louisiana State University astronomer Tabitha Boyajian, working with citizen scientists combing through Kepler data, found a star that didn't follow any version of those rules. KIC 846-2852, nicknamed Tabby's star, 1,470 light-years away in the constellation Cygnus, had been dimming erratically. Not by 1%, not by 5%, by up to 22% of its total brightness for periods of days to weeks, with absolutely no repeating pattern. Andrew Vanderberg at the University of Texas at Austin put it plainly, "We've never seen anything like this in Kepler. Kepler's looked at 500,000 stars. Nothing else anywhere in the dataset came close." Here's the problem. A 22% dip in a star's brightness is enormous. For context, a Jupiter-sized planet crossing a sun-like star produces about 1% dimming. To block 22% of Tabby's star's light, whatever is doing it would need to be larger than the star itself. But the dimming is different every time. Varying depths, varying durations, which rules out any solid object. The light is also blocked unevenly across different wavelengths, which rules out any large opaque structure. And here's the piece that doesn't get enough attention. Archival data from photographic plates stretching back to 1890 shows that Tabby's star has been slowly fading in overall brightness for over 130 years. Not in dips. Steadily. Continuously. One slow drain alongside the random flickers. There is no single known natural mechanism that simultaneously explains all of these behaviors. Not one. Imagine a spotlight in a dark room. Normal objects crossing in front of it cast clean, predictable shadows. But Tabby's star is like watching that spotlight flicker for no reason. A shadow appears for 3 days, then nothing for weeks, then one for 8 days, then 2 quick ones. The shadow is a different size every time, and it blocks some colors of light more than others. And the spotlight itself has been slowly getting dimmer since before your great-grandparents were born. You've searched the entire room. There's nothing casting the shadow. But the shadow keeps appearing. But it gets worse. The list of serious scientific proposals for Tabby's star includes swarms of comets, a disintegrating exomoon, irregular star spots, and a Dyson swarm, a theoretical megastructure built by a technologically advanced civilization to harvest energy from their star. This is not internet speculation. Penn State astronomer Jason Wright formally investigated and published on this hypothesis. The alien megastructure theory was ultimately disfavored because dust seems to be involved. But here's the sentence that rarely gets said aloud. It was disfavored, not disproven. Every natural explanation accounts for some of the data. None accounts for all of it. As of 2024, after nearly a decade of continuous monitoring by telescopes around the world, no single theory fully explains every aspect of what Kepler recorded. The star is still being watched. It is still doing it. If you were to step outside tonight and look toward the constellation Cygnus, you are looking in the direction of something we cannot classify, 1,470 light-years away. A star is behaving in a way that has exhausted every obvious explanation. It is still, formally scientifically, possible that it is something built. And here's the part that should stay with you. We will likely never know for certain. It is too far away, too complex, and too strange to resolve cleanly. It is going to keep dimming and flickering on no schedule for reasons we may never fully pin down. We just have to live with not knowing. Tabby's star is a question written in starlight across 1,470 years of distance. We looked at 500,000 stars and found exactly one that behaved like this, which means either we found one extraordinarily rare natural event or we found something else entirely. We are detectives who've processed every piece of evidence and still cannot eliminate the most unsettling suspect. The night sky looks quiet. It looks like it's just sitting there. But 7 stars in our own galaxy are currently doing things that no textbook category can contain, dimming without cause, screaming in dead silence, glowing with elements that should have vanished before life existed on Earth. They are not mysteries waiting to be explained. They are evidence that the universe is keeping things from us, not out of secrecy, but simply because we are very new here and very small, and still figuring out which questions to ask. If you want to see more videos like this, click the video on screen now and make sure to subscribe.